This is Mohammad Sadiq Rahman. So today I'm recording my understanding of experiment number 5, that is convolutional neural network (CNN). So CNN is convolutional neural network is a special types of training model by which we can detect some image or some edges and some sophisticated features. So that's why there is a problem. So we're just going through the problem. That is, at first we're just importing all the um, mm, Python functions, TensorFlow from Keras. This is very important for CNN modeling. And MNIST, this is the data set where we will load our data. And for creating the CNN models, we are importing the sequential model function. And in the CNN model, there are so many layers that is called dense layer. It's also called a fully connected layer, flattened layer that converts the image into one-dimensional array, and some dropout functions that randomly eliminates some of the neurons from a layer, and a convolution 2D and max pooling operation that takes that just reduces the size of the image based on the maximum value of this kernel, that is 2 by 2 or 3 by 3. And we can also use it on mean pooling or average pooling and so on. But in this problem, we are using max pooling operation. So at first, we're just loading our data from mni.load.data, and this automatically splits the dataset into training and test dataset. And whenever we are just printing the shape, we are observing that is in this dataset there is 60,000 of images, that is for training dataset, and 10,000 of images for test dataset, and each having a 28 by 28 pixel. And this is only one channel, so this is not RGB images, this is grayscale images. So there are 60,000 training dataset and 10,000 images for testing purpose. So this is the 28 by 20, that is the pixel values. And whenever we are observing the shape, that is 28, 28 equal to 1 is for grayscale. And whenever we just want to plot the data set, then this is the function that plots the images from this data set. And before plotting, we're just normalizing the values, because whenever we just plot our X-trained data set, we'll see some values from 0 to 255, that is for different types of pixels. So whenever we are normalizing it, it is easier for the model to train the dataset. That's why we are just normalizing it by dividing any value by 255, so that the training dataset and test dataset value can vary between 0 and 1. It will nothing but make the model easier to train for the training purpose. And to train and converting the output class vector to binary matrices, we are just using this function, that is utils to categorical, that will convert the class vectors to binary matrices. And this is the output. And here you can see this is a multi-class problem. So there are in total 10 classes from 0 to 9. Now we'll just build up our CNN model. For this, we are just importing our sequential model, and we'll have to add some layers. So at first, we are just adding first layer that consists of 32 filters, and each filter having size 3 by 3. And we have to do some activation functions. And this is we are using for a nonlinear function, that is a ReLU function. And we are also giving the shape. This shape is already defined as input shape, and this is nothing but this is 22, 28, 28 pixel values. So this is the first layer we just added, that is some filters, 32 filters, and with some activation function. Then we are adding another function, another layer that is consists of 64 filters having 3 by 3 kernel size and activation and ReLU functions. Then after adding these two layers, we are adding a max pooling operation. This is a max pooling layer that does nothing but to reduce the size of this image, and it takes the from each 2 by 2 matrices, it takes the maximum value and it just reduces the size of the image, output image. Then we are applying some dropout function that is from the output of this max pooling layer. It just randomly drop out 25% of the neurons, so that for the consecutive two layers, the neurons are randomly connected, so that it just enhances the randomizing process of the from the interconnection of these layers. And after the dropout, we are just using the flatten layer that just creates an 1D array of all the image values. That is, it's just only a single array. This is called the features of the input layers. And then we're just using our fully connected layers. The first fully connected layers consists of 128 neurons, and that creates an activation function ReLU with some bias. Then again, after the fully connected layers, we are using dropout. That is 1/4 of the neurons will be randomly deleted, and the next fully connected layer, that is the DENS layer, and it has 10 classes. And as it is 10 classes, this is not a binary problem. If it was a binary problem, we could use sigmoid activation function, but for the multi-class problems, we are using softmax. This is the most popular classifier for multi-class problems. So after adding 2 layers, max pooling operation, and flatten layer, the 3 layer, and the finally 2 fully connected layer, we are just displaying our model summary, and it is telling that in total this amount of parameters have been produced during this training purpose. And then we are just want to evaluate our model. That is, we are just evaluate the loss function, the optimizer, and the matrices accuracy. And for optimizer, we are using Adam, and for loss function, we are using cross entropy categorical. But it's not. We can also use binary entropy, but it is for multi-class problem. We are using cross entropy. And here we are just fitting the model from X train and Y train, and it's the epoch, and this is a verbose equal 1. The verbose is nothing but how we want to see our output after the training purpose. If we put it 0, then it will show nothing, and if we put 1, we can see how the training is being performed. And we are just want to train the find the accuracy of train test data set, and we are just giving it a score. And whenever we just print the score, we can see that the loss function is very low, accuracy going to 94%, and validation dataset accuracy 98%. This is quite pretty good actually, because this is a big dataset. So the CNN model can perform the training purpose very well, and it can predict the test dataset in a greater accuracy. And then finally, we can just save our model, so that if we want to train some other new things or some other prediction using this model, we can use it directly. So this is the final test accuracy, 98.42%, as it is being a very higher dataset. The CNN model performs very well. That's all. That's all for this assignment. Thank you.